Hello YouTube, this is Mr. Bakari, and today we're going to complete the square for conics. Specifically, we're going to complete the square to write vertex form of a parabola. All right, so typically in a conics unit, you're given some type of equation, and the first thing you want to figure out is what conic is this? So the giveaway that this is a parabola, as you can see, is only one of the variables is squared, okay? So with ellipses, with circles, and with hyperbolas, both variables are squared. So that's how we know this is a parabola. Now, x specifically is squared, so that tells us that this is a vertical parabola, all right? Now, the first thing we want to do is, or what I like to do is I'm going to rewrite this in standard form. And that is I'm going to solve for y and I'm going to write my terms in descending order of exponent power. Okay. So I'm going to rewrite this and I'm going to move the y term to the other side of the equation. Okay. So I want to write this in terms of y. So I'm going to take both sides and divide them by negative 2. Okay? So that gives me negative 1 half x squared plus 3x minus 5 halves equals y. Okay? So now it's in standard form. I like to write this first, establish that our a value, okay, is negative 1 half. All right? So now we're going to complete the square. So when we complete the square, you're asking what number do I need to add so this expression becomes a perfect square? So we have a little bit of work to do first. When you complete the square, we factor the leading coefficient only from the squared and the linear terms, never from the constant term. Okay? But this must be done before you complete the square. So I am going to factor out negative 1 half. Okay? So now I'm looking at negative 1 half times what will give me negative 1 half x squared. That's just x squared. What times negative 1 half will give me positive 3x, and that will be negative 6x. Okay, always just kind of multiply back, double check that. All right. And like I said, we don't want to mess with the constant. Okay. We're going to leave that alone. Okay. The constant is not part of the square that we're building here. So it gets handled separately to keep the equation balanced. All right. So like I said, when we complete the square, we're looking at what number do I need to add so this expression becomes a perfect square. So what we need to do is we need to take our coefficient here, all right, b, and half it and square that. Okay, so if we take negative 6 and we half it and square that, we get positive 9. Okay, now it appears at first glance that we added 9 to the left side of this equation, but you have to remember that we factored out negative 1 half. So this 9 gets multiplied by negative 1 half. So in fact, we subtracted 9 halves. Now, typically you would come over to the other side of the equation and you would do the same. So if I subtracted 9 halves on the left, I would subtract 9 halves on the right. But I don't need to put anything over here. So what I'm going to do instead is add 9 halves to the same side of the equation. And it's as if I did nothing at all. The equation remains balanced. Okay? All right. So now I'm ready to simplify this and write vertex form. So I'm going to bring down our a value, negative 1 half. Okay? And so what we've built here is a perfect square trinomial. So I'm going to factor that to x minus 3 squared. I'm going to combine like terms over here. Negative 5 halves plus 9 halves is 4 halves, which is just 2, equals y. And now we have our vertex form. So if we were going to graph our parabola and look for the focus and the directrix and all of that, we would work from here. Okay? All right, let's try another one. Okay, again, I'm studying this equation and I see that only one of the variables is squared, so I know it's a parabola. And this time, y is squared. So I know that it is a horizontal parabola. So what I'm going to do is I'm going to write this in standard form. So since it's a horizontal, I need to write it in terms of x. So I'm going to rewrite this and I'm going to move my x term over. Okay? And then divide by negative 12. All right, that gives me negative 1/12 y squared plus 1/2 y minus 9/12 equals x. Okay? Now it's in standard form. Now I will get it ready to complete the square. All right? So again, you can go right to completing the square if your leading coefficient is 1. If it is not, you got to factor it out first. So that's what we're going to do here. I'm going to factor out negative 1/12. Okay, negative 1/12 and y squared will give me negative 1/12 y squared. What times negative 1/12 will give me a positive 1/2 y? Okay, so you want to think about that. And you should get negative 6y. So check that out. Negative 6y times negative 1/12, positive 1/2 y. So that checks out. Now, again, we are going to leave the constant alone. So I'll just put it right back there. Leave a little room here to complete the square. Okay, so now again, we're going to take b, that is going to be negative 6, going to half it, and square that. Okay? So half of negative 6 is negative 3. Square that, we get plus 9. Okay? All right. So again, it appears that I added 9, but since we did factor this out, we really subtracted 9/12. So I'm going to come over here and I'm going to add 9/12 to the same side, which will cancel that out. Okay? All right. Now we're ready to write vertex form. I'm going to bring down A. I'm going to factor my perfect square trinomial here. Y minus 3 squared. Combine terms, and negative 9/12 plus 9/12 is just 0 equals x. And that is my vertex form. All right. So hopefully this exercise helps you out. It's really important to practice this before you complete the square with ellipses and hyperbolas and circles, because there you've got two squared variables, so you're going to complete the square twice. So practice this and apply that to the other conics. All right, I'll see you in the next video.